In this video, we're going to cover question number 1 from 2017. This was a you-do problem. So if you haven't done it yet, make sure you hit pause and complete it before you watch the rest of this video. This is a table problem. This type 3, is all about tables. So a tank has a height of 10 feet. The area of the horizontal cross-section of the tank at height h feet is given by the function a, where a of h is measured in square feet. The function a is continuous and decreasing as h increases. Select values of a of h are given in the table above. So we have a tank that has a constant height of 10 feet, and the area of the horizontal cross sections of the tank at different heights is given by function a. So that means that the width or the shape of this tank is changing as we move up the height of it. So it says use a left Riemann sum with 3 subintervals indicated by the data in the table to approximate the volume of the tank. So this particular problem is actually combining the the volume of regions that have cross sections with a Riemann sum. So this is kind of not the norm of what we've done in the past, but it's a good example of how these types of problems can merge. So remember, when we're looking for volume and we're talking about cross sections, the volume of any object with cross sections is going to be the integral of the area expression. So that's why I have a of h dh here. It's the integral of the area. So we're finding the area of one cross section and we're multiplying it by dh, and dh is basically the change in the height. It's that height of that one cross section, and then we're summing up all of those, whatever they are, prisms or little cylinders or whatever they are, but we're looking for the volume from 0 to 10. So we're doing a Riemann sum of this, and notice the table gives you values of the area. And so we can just do a normal Riemann sum, and it says we're doing 3 subintervals, and we're doing a left Riemann sum. So the first subinterval is from 0 to 2, so the width is 2. The height is going to be the left-hand value out of the two outputs, so we're going to use 50.3 as our height for the first rectangle, and then we're going to add to it the width of the next one, which is 3 times 14.4, because that's the left hand of those two options, and then the width of the third triangle is going to be 5, and then multiply that by the left hand value of 6.5, and then we can simplify it from there, and we end up with 176.3. Now it asks us to indicate the units of measure. Well, this should be pretty straightforward. Because we're talking about volume, it's going to be something cubed, and because we're talking about feet, it's going to be feet cubed. But to try and understand that a little bit more, because we're taking the integral of the area is square feet, and we're multiplying it by the change in the height, and the units on the height are feet. So we have square feet times feet, which is feet cubed. The other thing I want to point out is that this is an approximation because we're doing a Riemann sum. We're not finding the exact integral, so we need to be putting the approximation sign between those. As far as points go, you're going to get 1 point for the left Riemann sum. That means you're getting 1 point for this expression right here, okay? The 2 times 50 plus 3 times 14 plus 5 times 6, and you're going to get 1 point for your approximation. Let's see here, 1 point for your approximation, and then I want to point out that again, we do not have to simplify all of this. We could have left it right here with this sum without any simplification. And again, I suggest that because we're prone to make mistakes going from this line to this line and then from this line to this line, just basic arithmetic mistakes. So if you just leave it here, then you would actually get both points. All right, for part B, it says, does the approximation in part A overestimate or underestimate the volume of the tank? Well, if we remember, a Riemann sum is an over-under approximation dependent on the direction of the function. So if the function is increasing or decreasing, that's going to tell us whether we have an over or under approximation. So it says in the prompt, it says that A is continuous and decreasing. Since A is decreasing, I'll put a little sketch here. Since A is decreasing and we're doing a left-hand Riemann sum, so if I cut this into rectangles, I'm doing a left-hand Riemann sum. That means I'm using the height of the left value here and going over and moving over. So we can see because the function is decreasing, the left-hand Riemann sum will be an over approximation. And so we have to include all of that information. Since A of h is a decreasing function, a left-hand Riemann sum will be an over approximation, okay, or an overestimate. Point values for this, you're going to get 1 point for your answer with the justification. So it's either right or wrong, and the justification has to be accurate as well. Okay, for part C, it says the area in square feet of the horizontal cross-section at height h feet is modeled by the function f of h. Based on this model, find the volume of the tank. So here, we're not estimating the volume, we're finding the actual volume. So we're still going to use the same equation here. It's going to be the integral from 0 to 10 of f of h dh. And then because this is a calculator problem, hopefully we save this into our y list, and then we can just plug that in. Integral of y1 parentheses x close parentheses comma x comma 0 comma 10, and we'll have our answer there. So we can see that the actual volume is 101.325 feet cubed. As far as points go, you get 1 point for having the correct integral expression, so basically 1 point for this guy, and then 1 point for your final answer. Alright, for part D, it says water is pumped into the tank. When the height of the water is 5 feet, the height is increasing at a rate of 0.26 feet per minute. Using the model in part C, find the rate at which the volume of water is changing with respect to time when the height of the water is 5 feet. Now, this seems like a lot of information, but we should notice that we are looking for the rate at which the volume of water is changing with respect to time. So we are actually looking for v prime of t. V prime of t. Well, this function that we have is f of h. Remember, f represents the area, and then we are looking for the rate of the volume. So we're looking for the derivative of the volume. So here we have an expression. Let's create a volume expression. The volume equation then would be the integral from 0 to h of f of x dx, because we're finding the volume in respect to, in this case, in respect to h the way it's written here. But remember, volume is equal to the integral of the area function, and I'm just putting this as a variable right now because here we were looking for the volume when the height was 10, but we're going to be looking for the rate as the amount of water increases. That means the volume is increasing, and as the volume increases, the height is changing. So the volume is going to be dependent on h in that case. That means things are changing. By making a 10 here, we're making the volume a constant thing. Anyways, back to the prompt here. It says we're looking for the rate of volume in respect to time. This tells me that I need to think of volume as a function of time, and therefore h is going to be a function of time. And we can see that here. It says the height is increasing at a rate of 0.26 foot per minute. So we have to think of volume in respect to time and h in respect to time. And because we're looking for the rate of the volume, we have to take the derivative of this. So the derivative of v is just v prime. But keeping in mind, let me take a step back here. Keeping in mind, when I put v prime, I really mean v prime of t. Now from here, we're going to take the derivative of our expression. Well, the derivative of an integral is pretty straightforward. Remember that taking the derivative of an integral, we plug in the upper bound, and then we multiply that by the derivative of the upper bound. So in this case, we're going to end up with f of h, because we plug in h, and then times the derivative of h. Remember, h is a function of time in this case. So then the derivative of h is going to be h prime. All right? And then remember, we have to subtract from that the lower bound. So we have to subtract, plugging in 0 to our integrand, and then multiplying it by the derivative of the lower bound. So that would say f of 0, and then times the derivative of 0, which is just 0. So this is the derivative function in respect to time. From here we can simplify this a little bit because the f of 0 times 0 cancels out. And so we're left with v prime equals f of h times h prime. So now going back to the prompt, it gives us some important information. It says that the height, when the height is 5 feet, so I indicated that here, that h is 5, the height is increasing at a rate of 0.26. So the height is increasing, that's telling us that h prime is 0.26. And in fact, that's all we need to figure out what v prime is. We can just plug in these values into our equation here. So we end up with v prime equal to f of 5 times 0.26. So h is 5, and then h prime is 0.26. And then from here, we've got to figure out what f of 5 is. So we would take 5 and plug it back into our f function for the height. So f of 5 is going to be 50.3 over e to the 0.2 times 5, and then plus 5. And then we can simplify from there. This is going to be a calculator problem, so you can just type that in, and you get 6.517. And then we can take that value and plug it into f of 5 here. And so you end up with 6.517 times 0.26, which is 1.694. And then the last part, it says indicate the units of measure. Well, the units of measure, because we're looking for v prime, and we are taking the rate in respect to time, we would have the volume over time. So volume is feet cubed, and then the time is in minutes here, so it's feet cubed per minute. As far as the breakdown of the grading, you would end up with 2 points for figuring out what v prime of t is. So basically 2 points for this expression here. And if you just put v prime equals f of h times h prime, that would be good too. And then you would get 1 point for your final answer. All right, for the last point, because if you notice, if you add up the 4 parts, that's only 8 points. And so for the last point, you would get a point if you have the correct units in A, C, and D. So if you just have the units right in one part, you don't get this final point here. All right, so that makes your 9th point. All right, that wraps up this question. So go ahead and grade it, and then move on to the next question, which is going to be 2016 number 1. This is a calculator-based problem. This is a quiz, so set a timer for 12 minutes, do it on your own, and then see how you do by watching the next video and grading yourself.